Before time had a name, before the faintest breath of existence stirred in the cosmic dark, there was nothing, no light, no matter, no space to contain them. And then, in an instant so brief that even the word instant trembles with inadequacy, the universe ignited. A blinding eruption of energy tore through the void, creating space itself as it expanded outward. That first heartbeat of being, the Big Bang, was not an explosion in space, it was the explosion of space. Every atom, every particle, every whisper of the future was born in that single act of genesis. Temperatures soared beyond comprehension, matter and energy indistinguishable, the newborn cosmos roaring with light no eye would ever see. In less than a trillionth of a second, it inflated from smaller than a proton to larger than galaxies, a flash of unimaginable scale, painting the canvas of eternity. As the young universe cooled, the primordial fire began to fade, and in that fading emerged form. Quarks bound together to form protons and neutrons, the building blocks of all atomic nuclei. It was the universe's first chemistry, a slow dance of attraction and annihilation. Matter barely triumphed over antimatter. One extra particle in every billion survived. And from those survivors, everything you know, everything you are, would one day arise. 3 minutes after creation, the first atoms of hydrogen and helium formed, the simplest elements, born from the furnace of the Big Bang itself. But the universe was still a sea of light and plasma, opaque and turbulent, a storm of creation awaiting calm. Hundreds of thousands of years later, that calm arrived. As temperatures dropped, electrons bound to nuclei, forming neutral atoms. The universe became transparent for the first time, allowing light to travel freely across space. That ancient light still glows today, faint but omnipresent, the cosmic microwave background, a whisper from the dawn of time. It drifts between galaxies, a ghostly echo of the universe's first light, carrying within it the coded map of creation. Every tiny variation in its temperature foretold the architecture of everything to come. The galaxies, the stars, the clusters, the filaments of matter that now span the heavens like a celestial web. In those vast, silent stretches of young space, gravity began its patient work. Hydrogen clouds gathered, pulled together by invisible threads, collapsing under their own weight. Within their cores, the first stars ignited, massive, brilliant, short-lived giants that burned with a fury unknown to the modern cosmos. They were made only of hydrogen and helium, yet within their fiery hearts they forged the heavier elements, carbon, oxygen, iron, the seeds of life and worlds. When they died spectacularly, exploding as supernovae that scattered those elements into the cosmic sea. The ashes of those first suns became the dust of creation, the material from which new stars and planets would be born.
Galaxies took shape, sprawling cities of stars held together by gravity and time. Some spun gracefully like whirlpools, others formed chaotic clusters. In the centers of many, monstrous black holes grew, invisible engines of gravity that devoured light itself. Around them, stars orbited in solemn reverence, their paths dictated by the hunger of darkness. Over billions of years, galaxies merged, collided, and reshaped one another. The Milky Way, the galaxy that would cradle our future home, began as one such merger, a gathering of smaller galaxies drawn together by cosmic fate. Each collision sparked new waves of starbirth, lighting up the galactic arms like fire along a spiral fuse. Far away in another arm of this newborn galaxy, a modest star began to form from a cloud of gas and dust, its surrounding disk swirling with potential. Out of that disk, through endless collisions and coalescence, emerged the planets, rocky and gaseous, vast and small, barren and alive. One nestled at just the right distance, cooled enough to cradle liquid water, and from that water came something the universe had never seen before: awareness. On that small blue world, the universe began to look back at itself. Humanity, though late to the cosmic story, inherited its curiosity from the stars, for the elements in our blood were born in their cores. When ancient peoples first lifted their eyes to the night sky, they saw eternity staring back. Without telescopes or science, they sensed the grandeur of what lay beyond. The Babylonians charted the motions of planets, calling them wandering stars. The Egyptians aligned their monuments to the rising of Sirius, herald of the Nile's flood. The Greeks, gazing from their marble coasts, began to ask what the heavens truly were. Thales of Miletus wondered if the universe had always existed. Anaximander dared to propose that the earth floated freely in space. Pythagoras, centuries ahead of his time, spoke of celestial harmony, a music of the spheres. Then came Aristotle, who imagined a universe of perfect circles and immutable heavens, a realm of divine order beyond the moon. His model reigned for 2 millennia, unchallenged and beloved, even as it confined humanity to the center of creation. But in the silence of the Renaissance, a Polish canon named Nicholas Copernicus would quietly rewrite the cosmos. In 1543, as his life waned, he published De Revolutionibus Orbium Celestium, declaring that Earth itself revolved around the sun. The shock was profound. Not only did it dethrone our planet, but it revealed motion where once there had been stillness. The universe was no longer a stage for divine perfection. It was a living, moving system governed by laws yet to be discovered. Galileo Galilei, with a crude telescope of his own making, aimed it toward the heavens and confirmed what Copernicus had dared to imagine. He saw mountains on the moon, moons around Jupiter, phases of Venus, evidence that Earth was not the center but a participant in a cosmic dance. For this truth, he faced the fury of an age unready to see. Yet the universe did not bend to doctrine. It continued to reveal itself. Kepler's laws showed that planets moved in ellipses, not circles, their speeds guided by
As telescopes grew, so too did the universe in human imagination. Herschel mapped the Milky Way and discovered Uranus, yet he could not conceive its true scale. Astronomers believed the stars formed the entirety of existence, scattered across a single island of light. It would take a century and a half and the power of modern glass and steel to show otherwise. When Edwin Hubble peered through the great telescope of Mount Wilson in the 1920s, he found galaxies beyond our own, vast, distant, innumerable. The Milky Way was not the universe, but one among billions. And those galaxies, he discovered, were all retreating from us, their light stretched to longer wavelengths, red with motion. The universe was expanding. The echo of the Big Bang still rang across the cosmos. Yet even as Hubble revealed expansion, the question deepened. What was the universe expanding into? The answer, astonishingly, was nothing. Space itself was stretching, carrying galaxies apart like raisins in a rising loaf of bread. There was no edge, no center, only a fabric that grew with time. In that revelation, human thought transcended its final boundary. The universe was not a fixed creation, but an evolving being, ancient and restless, governed by laws yet incomplete. Einstein had already sensed this when he formulated his theory of general relativity, a vision of gravity not as a force, but as the curvature of space-time. Massive objects bend space, and in that bending, other objects move. Light itself follows those curves, revealing invisible structures by the way it bends and warps around them. Einstein's equations predicted wonders he himself found unsettling. Among them was the black hole, a point where space-time becomes so warped that it folds in upon itself, trapping even light. For decades, it remained a mathematical curiosity, too strange to be real. But nature, indifferent to our hesitation, had already forged them in abundance. When giant stars exhaust their fuel, they collapse inward, their matter crushed to infinite density. Around these invisible hearts, space twists into an abyss where time slows to a crawl. To fall into one is to vanish from the universe's memory. And yet paradoxically, Their existence shapes galaxies, drives evolution, and perhaps even helps weave the fabric of the cosmos itself. By the mid-20th century, humankind had begun to listen to the universe in new ways. Radio telescopes captured whispers from the stars, revealing signals that once would have been dismissed as divine. In 1965, two engineers at Bell Labs, Arno Penzias and Robert Wilson, stumbled upon a faint hum of microwaves from every direction. It was not interference. It was the cosmic background, the afterglow of the Big Bang, still washing over Earth after nearly 14 billion years. The universe itself.
As telescopes grew, so too did the universe in human imagination. Herschel mapped the Milky Way and discovered Uranus, yet even he could not conceive its true scale. Astronomers believed the stars formed the entirety of existence, scattered across a single island of light. It would take a century and a half, and the power of modern glass and steel to show otherwise. When Edwin Hubble peered through the great telescope of Mount Wilson in the 1920s, he found galaxies beyond our own, vast, distant, innumerable. The Milky Way was not the universe, but one among billions. And those galaxies he discovered were all retreating from us, their light stretched to longer wavelengths, red with motion. The universe was expanding. The echo of the Big Bang still rang across the cosmos. Yet even as Hubble revealed expansion, the question deepened. What was the universe expanding into? The answer, astonishingly, was nothing. Space itself was stretching, carrying galaxies apart like raisins in a rising loaf of bread. There was no edge, no center, only a fabric that grew with time. In that revelation, human thought transcended its final boundary. The universe was not a fixed creation, but an evolving being, ancient and restless, governed by laws yet incomplete. Einstein had already sensed this when he formulated his theory of general relativity, a vision of gravity not as a force, but as the curvature of space-time. Massive objects bend space, and in that bending, other objects move. Light itself follows those curves, revealing invisible structures by the way it bends and warps around them. Einstein's equations predicted wonders he himself found unsettling. Among them was the black hole, a point where space-time becomes so warped that it folds in upon itself, trapping even light. For decades, it remained a mathematical curiosity, too strange to be real. But nature, indifferent to our hesitation, had already forged them in abundance. When giant stars exhaust their fuel, they collapse inward, their matter crushed to infinite density. Around these invisible hearts, space twists into an abyss where time slows to a crawl. To fall into one is to vanish from the universe's memory. And yet, paradoxically, their existence shapes galaxies, drives evolution, and perhaps even helps weave the fabric of the cosmos itself. By the mid-20th century, humankind had begun to listen to the universe in new ways. Radio telescopes captured whispers from the stars, revealing signals that once would have been dismissed as divine. In 1965, two engineers at Bell Labs, Arno Pignaz and Robert Wilson, stumbled.
It is one of nature's strangest economies. Nothing is lost, only transformed. The gold in a ring, the silicon in a microchip, the oxygen that sustains breath, all were once forged in the heart of a dying star. The cosmos is an alchemist, transmuting hydrogen into the building blocks of life, scattering them across billions of light years in bursts of stellar death. When those atoms finally gathered again, coalescing into a planet orbiting an ordinary star in an ordinary arm of an ordinary galaxy, the improbable happened. Life emerged, and with it, awareness. On that small sphere of rock and water, matter learned to wonder about itself. A single species, evolved from the dust of exploded suns, would one day stand beneath the night and ask, "What is out there?" Through ages of curiosity and courage, that question would evolve into science. The 17th century gave us the telescope. The 20th gave us radio astronomy, spectroscopy, particle physics, and cosmology. We now peer into wavelengths unseen by human eyes: infrared, ultraviolet, X-ray, gamma, and each reveals a new universe layered upon the old. In the radio spectrum, we find the relics of ancient galaxies. In X-rays, the violent signatures of black holes devouring matter. In infrared, the tender glow of newborn stars still shrouded in dust. The universe is not a silent void, but a symphony of invisible light, and we are just learning the score. Among its movements, the most dramatic are performed by black holes. These invisible giants are the sculptures of galaxies, the unseen conductors of cosmic order. At the center of the Milky Way lurks Sagittarius A star, a supermassive black hole 4 million times the mass of the Sun. Around it, stars whip in tight orbits at thousands of kilometers per second, tracing the outline of a darkness they can never touch. When matter falls into such an abyss, it forms an accretion disk, spirals of gas heated to millions of degrees, radiating more energy than 1,000,000 suns. From these,
Time itself, once thought universal, is not a constant in the cosmos. Einstein revealed that it flows differently depending on gravity and motion. Clocks tick slower near massive bodies, faster in the emptiness of deep space. The GPS satellites orbiting Earth must account for this relativity, or our navigation systems would drift miles off course within days. In the grand cosmic theater, time is elastic, molded by the geometry of space-time. The early universe, compressed and dense, experienced time differently than the vast, stretched cosmos we inhabit now. In a very real sense, the universe has aged not evenly, but dynamically, its moments expanding like the fabric that carries them. And that fabric, the cosmic web, is woven of both seen and unseen threads. Galaxies cluster along filaments of dark matter, separated by vast voids almost empty of substance. Supercomputers have simulated this structure, revealing an intricate lattice stretching across billions of light years. It is a cosmic architecture more elaborate than any cathedral, more enduring than any civilization. Within those threads, gravity draws galaxies together into clusters and clusters into superclusters. The largest known structure, the Hercules Corona Borealis Great Wall, spans 10 billion light-years, an expanse so vast that light itself would need 100 million centuries to cross it. Yet even this colossal web is merely a fraction of what may exist beyond our observable horizon. The observable universe is limited not by space, but by time. Light travels at a finite speed, and the cosmos has a finite age. We can see only as far as light has had time to reach us, about 13.8 billion years. But because space has expanded in the interim, those regions are now nearly 46 billion light-years away. Beyond that lies the unobservable, realms forever hidden from our view, expanding away faster than light can bridge the gap. To speak of the universe's edge is to misunderstand its nature. There is no boundary, only the fading of visibility, like a ship vanishing into mist, not because it has reached the end of the sea, but because the sea curves endlessly onward. And within that sea, the laws of physics hold dominion, or so we believe. Yet even those laws may not be eternal. The constants of nature, light speed, Planck's constant, gravitational strength, seem unchanging, but physicists wonder if they have always been so. If the early universe was governed by slightly different rules, it might explain why matter triumphed over antimatter, why galaxies formed when they did, why the cosmos evolved toward complexity rather than chaos. Each new discovery reveals that the universe is not a...
Such discoveries have transformed cosmology from philosophy into precision science. We can now measure the age of the universe with astonishing accuracy, track its expansion, map its composition, and predict its fate. Yet those predictions are haunting. If dark energy continues to dominate, galaxies will drift ever farther apart until their light fades beyond perception. Stars will exhaust their fuel, leaving only remnants, white dwarfs, neutron stars, and black holes. Over trillions of years, even those will evaporate through Hawking radiation.
their mass dissolving into photons. The universe will grow cold, dark, and silent, a vast entropy of emptiness. And yet, perhaps even that is not the end. Quantum fluctuations may spark new universes, new Big Bangs, rebirth from decay, an eternal cycle of creation beyond imagination. To contemplate such scales is to confront humility, the human lifespan, the rise and fall of empires, the entire span of recorded history, all are less than a blink in cosmic time. Yet within that blink, humanity has reached beyond its cradle. We have walked upon another world, sent probes to the edge of the solar system, and photographed galaxies billions of years old. The Voyager spacecraft, launched in 1977, now drifts in interstellar space, carrying with it a golden record, a message of music, images, and greetings from Earth, destined perhaps to outlast all our monuments. Somewhere in the cold between stars, it continues its lonely voyage, a fragment of our species whispering into infinity. The solar system itself is a microcosm of cosmic diversity. The Sun, a middle-aged star, burns with the same nuclear fire that illuminates the Milky Way. Around it dance 8 planets, each a world unto itself. Mercury, scorched and airless, circles closest, a relic of the solar system's infancy. Venus, shrouded in clouds of acid and heat, is a mirror of what Earth might have been under different circumstances. Our own world teems with life, balanced precariously between ice and flame. Beyond it lies Mars, its red deserts etched in ancient riverbeds, signs that it once too had seas and perhaps the chemistry of life. Farther still lies Jupiter, a storm-racked giant whose gravity shepherds asteroids and moons like a cosmic monarch. Saturn, with its rings of ice and dust, is a cathedral in motion. Uranus and Neptune, pale sentinels at the edge, swirl with methane clouds in the dim sunlight. Beyond Neptune lies the Kuiper Belt, a vast icy remnants, comets and dwarf planets like Pluto. Beyond that even lies the Oort cloud, a vast spherical shell of frozen debris extending halfway to the nearest star. It is the solar system's ghostly boundary, the source of long-period comets that occasionally fall inward, blazing across our skies before vanishing back into the void. Every comet, every asteroid, every speck of interplanetary dust is a time capsule from the birth of the Sun, untouched for billions of years. To study them is to read the earliest pages of our planetary story.
Such discoveries have transformed cosmology from philosophy into precision science. We can now measure the age of the universe with astonishing accuracy, track its expansion, map its composition, and predict its fate. Yet those predictions are haunting.
If dark energy continues to dominate, galaxies will drift ever farther apart until their light fades beyond perception. Stars will exhaust their fuel, leaving only remnants, white dwarfs, neutron stars, and black holes. Over trillions of years, even those will evaporate through Hawking radiation, their mass dissolving into photons. The universe will grow cold, dark, and silent, a vast entropy of emptiness. And yet, perhaps even that is not the end. Quantum fluctuations may spark new universes, new Big Bangs, rebirth from decay, an eternal cycle of creation beyond imagination. To contemplate such scales is to confront humility. The human lifespan, the rise and fall of empires, the entire span of recorded history, all are less than a blink in cosmic time. Yet within that blink, humanity has reached beyond its cradle. We have walked upon another world, sent probes to the edge of the solar system, and photographed galaxies billions of years old. The Voyager spacecraft, launched in 1977, now drifts in interstellar space, carrying with it a golden record, a message of music, images, and greetings from Earth, destined perhaps to outlast all our monuments. Somewhere in the cold between stars, it continues its lonely voyage, a fragment of our species whispering into infinity. The solar system itself is a microcosm of cosmic diversity. The Sun, a middle-aged star, burns with the same nuclear fire that illuminates the Milky Way. Around it dance 8 planets, each a world unto itself. Mercury, scorched and airless, circles closest, a relic of the solar system's infancy. Venus, shrouded in clouds of acid and heat, is a mirror of what Earth might have been under different circumstances. Our own world teems with life, balanced precariously between ice and flame. Beyond it lies Mars, its red deserts etched with ancient riverbeds, signs that it once too had seas, and perhaps the chemistry of life. Farther still lies Jupiter, a storm-racked giant whose gravity shepherds asteroids and moons like a cosmic monarch. Saturn, with its rings of ice and dust, is a cathedral in motion. Uranus and Neptune, pale sentinels at the edge, swirl with methane clouds in the dim sunlight. Beyond Neptune lies the Kuiper Belt, a vast icy remnants, comets and dwarf planets like Pluto. Beyond even that lies the Oort cloud, a vast spherical shell of frozen debris extending halfway to the nearest star. It is the solar system's ghostly boundary, the source of long-period comets that occasionally fall inward, blazing across our skies before vanishing back into the void. Every comet, every asteroid, every speck of interplanetary dust is a time capsule from the birth of the sun, untouched for billions of years. To study them is to read the earliest pages of our planetary story.
Even space, once thought to be mere emptiness, is dynamic. It bends, stretches, vibrates with gravitational waves, and perhaps even quantizes at scales so tiny we cannot yet measure. Time may not flow uniformly, but emerge from interactions between quantum events, a statistical property of matter itself. If so, the universe is not a machine running on time, but a process that creates time as it unfolds. Such ideas are not poetry, but the frontier of physics as researchers probe deeper into the origins of everything. What lay before the Big Bang? Was it a singularity, a boundary, or a transition from a previous universe? The answers remain buried in mathematics, awaiting insight as profound as those of Newton, Einstein, or Hawking. Yet, even as we reach for those abstractions, the universe remains a place of tangible wonder. The nebulae, those vast clouds of gas and dust, are both tomb and womb, remnants of dead stars and the nurseries of new ones. The Orion Nebula, visible even to the naked eye, harbors thousands of young stars forming within its luminous folds. Each glimmer is a potential solar system, a potential story. The pillars of creation, immortalized by the Hubble telescope, are not sculptures of stone, but columns of gas light years tall, slowly eroding under the radiation of nearby stars. We see them as they were 7,000 years ago. By now, they may already have vanished. The images we revere are not photographs of the present, but messages from the past, each photon a courier bearing news from ages gone. Light is the great historian of the universe. It travels tirelessly, crossing gulfs of time and space, recording every event in its wavelength. When we observe distant galaxies, we are not seeing them as they are, but as they were, billions of years ago. The deeper we look, the further back we go, until we approach the very dawn of existence. The James Webb Space Telescope, launched into the darkness beyond the moon's glare, has pushed our gaze to the earliest galaxies, shimmering less than 1 billion years after the Big Bang. Some are unexpectedly massive, challenging our theories of how quickly structure could form. Each new observation rewrites the timeline, forcing us to confront the limits of our understanding. For much of history, humanity believed that everything beyond the stars was immutable, eternal. But now we know the universe evolves on every scale. Galaxies collide in slow motion, merging into new forms. The Milky Way itself is on a collision course with the Andromeda Galaxy, a vast encounter that will unfold 4 billion years from now. When they meet, their stars will pass mostly unharmed through the immense voids between them, but gravity will reshape them into a single elliptical galaxy, perhaps to be called Milkandromeda. The night sky then will blaze with countless suns, a spectacle unseen since the dawn of time. And yet, by that era, our sun will be nearing the end of its life, swelling into a red giant that will consume Mercury and Venus, perhaps even Earth. Long before then, humanity, or its descendants, must seek new homes among the stars.
That exodus may already be written into the logic
of life. Evolution favors curiosity, and curiosity drives expansion. The universe invites exploration, and life answers. In that sense, consciousness may be the universe's method of understanding itself, a natural extension of the same laws that gave birth to stars and galaxies. From the fusion in a stellar core to the firing of neurons in a human brain, the pattern is continuity, energy organizing into complexity. We are not separate from the cosmos, but expressions of it, momentary configurations of its ancient elements arranged into awareness. To look outward is, therefore, to look inward. But the universe's beauty is not confined to its grandeur. It resides in its precision. The constants of nature are balanced with exquisite delicacy. If the gravitational constant were slightly stronger, stars would burn out too quickly. Slightly weaker, and they would never ignite. If the cosmological constant differed by even a fraction, the universe would have collapsed or expanded too fast for matter to coalesce. The charge of the electron, the strength of the nuclear force, the ratio of proton to neutron mass, all fall within narrow ranges that permit atoms, chemistry, and life. Whether this balance is coincidence, necessity, or evidence of deeper design remains one of science's most profound questions. It may be that countless universes exist, each with different parameters, and we inhabit the one where existence is possible. The multiverse theory, though speculative, offers a framework where our universe is not unique, but one among an infinite ensemble. If there are other universes, they are forever beyond our reach, separated by dimensions or inflating space. Yet their possibility humbles us. The cosmos we can see is already beyond comprehension. 2 trillion galaxies, each with hundreds of billions of stars, stretching across observable space. And still, this is but a fraction of reality. Our instruments capture only the visible spectrum, a narrow sliver of the electromagnetic range. Beyond it lies radio waves kilometers long, gamma rays smaller than atoms, and perhaps phenomena we have not yet conceived. To the universe, human senses are primitive. To understand it, we must extend them through technology. Every telescope, every detector, every probe is an organ of perception added to the collective body of our species. As technology advanced, so too did our capacity to measure time itself. The cosmic timeline, once unknowable, is now charted with remarkable detail. The first seconds after the Big Bang saw the birth of fundamental forces, gravity, electromagnetism, and the strong and weak nuclear forces. Within minutes came nucleosynthesis, the creation of hydrogen, helium, and traces of lithium. For hundreds of millions of years, darkness reigned, until the first stars pierced it with light. Galaxies formed, merged, evolved. 9 billion years later, the Sun and its planets emerged. 4.5 billion years after that, a species capable of memory arose. The universe is 13.8 billion years old, yet its history is still young compared to what lies ahead.
For time stretches not just backward, but forward into near eternity. Trillions of years from now, the last stars will flicker out. Even the black holes will evaporate, their energy dissipating into faint radiation. In that far future, the universe will be a thin mist of particles, expanding endlessly, temperature approaching absolute zero. It will be a cosmos without light, without form, yet perhaps not without potential. Quantum physics allows for spontaneous fluctuations, even in emptiness, and from one such fluctuation, a new universe could be born, a new Big Bang, a new dawn. In that sense, death itself is only transformation on a universal scale. But between the beginning and that distant end lies our moment, the thin, golden interval of cosmic history where stars still shine and life still dreams. Humanity exists in a privileged era, balanced between the ancient fire of creation and the long twilight to come. We are witnesses to a universe in bloom, capable of seeing its past and imagining its future. And though our understanding is incomplete, every discovery expands the horizon of wonder. Even now, new mysteries unfold. Fast radio bursts, immense pulses of energy lasting milliseconds, flash across the cosmos, their origins uncertain. Perhaps they are the deaths of magnetars, perhaps something stranger. Quasars blaze with the light of 1 trillion suns, powered by black holes at the centers of young galaxies. Pulsars spin like cosmic lighthouses, their beams sweeping the sky with mechanical precision. The cosmic microwave background, once thought uniform, reveals subtle anomalies hinting at deeper structure. And still the question remains, why is there something rather than nothing? Every answer seems to unfold into deeper riddles, each layer of comprehension revealing another below. Yet to dwell only on mystery is to overlook the majesty of what is known. The laws of physics, from the quantum to the cosmic, weave a coherent story of existence. They govern the arcs of comets, the shimmer of auroras, the growth of crystals, the pulse of hearts. Through them, the universe achieves continuity, binding the vast and the minute in the same grand design. To understand these laws is to participate in creation, not as spectators, but as conscious elements of the process itself. And that, perhaps, is the most astonishing fact of all.
From the cold silence between stars to the blazing hearts of quasars, the universe speaks in frequencies. Each wave, radio, microwave, infrared, visible, ultraviolet, X-ray, and gamma, is a voice in a cosmic choir whose song has never ended since the first moment of creation. When astronomers build instruments to capture these whispers, they are not merely observing, they are listening to history. The hiss of the cosmic microwave background, the rhythmic pulse of a distant pulsar, the soft murmur of interstellar hydrogen at 21 centimeters. All are archives of events billions of years old.
That past stretches beyond imagination. Before galaxies coalesced, the universe was a mist of hydrogen and helium. The first stars were titans, hundreds of times more massive than the sun, living fast and dying young. Their ultraviolet light reionized the cosmos, transforming darkness into transparency. Their deaths seeded the universe with metals, astronomers' term for all elements heavier than helium, and made possible the chemistry of planets and life. Without those primordial stars, there would be no carbon for cells, no oxygen for breath, no silicon for stone. Their brief brilliance paved the way for complexity. Though they vanished billions of years ago, their legacy endures in every atom of your being. The Milky Way, our galactic home, is a spiral of roughly 200 billion stars. It measures 100,000 light-years across and rotates once every 200 million years. From our vantage point within one of its arms, we see its structure only obliquely, as a pale river across the sky, the Milky Way of myth and poetry. Yet beneath its serenity lies turmoil, stars forming and dying, clouds collapsing, shock waves rippling through interstellar space. The sun orbits the galactic center at 220 kilometers per second, accompanied by its retinue of planets. It has completed only about 20 such orbits since its birth. Around it drift comets, asteroids, and dust, remnants of the nebula that gave us birth. Beyond our galaxy stretch others in staggering numbers. Some are dwarfs containing a few million stars. Others, like IC 1101, span 6 million light-years and harbor 100 trillion. Between them lies the intergalactic medium, a tenuous plasma where atoms are separated by vast distances. Yet even emptiness is not truly empty. Photons from ancient stars wander eternally through this darkness, occasionally scattering off stray electrons or encountering clouds of gas that absorb and re-emit their light. Astronomers trace these interactions to map the structure of the cosmos, revealing filaments and voids on scales beyond human comprehension. The visible universe forms a pattern
eerily reminiscent of neural networks, as though the cosmos itself were a mind contemplating its own existence. Among the billions of galaxies, some stand out for their violence. Starburst galaxies form stars at thousands of times the rate of the Milky Way, their cores ablaze with newborn suns. Active galactic nuclei unleash torrents of radiation as matter spirals into their central black holes. Quasars, visible across the observable universe, shine with a brilliance that defies reason, their energy drawn from the fall of matter into gravitational abysses. The most distant quasars we see today existed when the universe was less than 1 billion years old. Their light has traveled for nearly 14 billion years to reach us, bearing witness to the cosmos's fiery youth. Closer to home, the solar system reveals subtler dramas. The planets follow orbits defined by gravity, but shaped by time. Jupiter's pull sculpts the asteroid belt.
And beyond the solar system lie the mysteries of interstellar space. The Voyager probes, humanity's messengers, now travel through this realm, measuring particles and magnetic fields where the sun's influence fades. They report a quiet unlike any experienced before, a silence older than the stars themselves. Yet, even there, cosmic rays from distant supernovae still whisper through the void, carrying information about cataclysms light years away. Each particle is a traveler, each photon a memory, each wave a message in transit across eternity. The more we explore, the more the boundaries between the known and the unknown dissolve. Quantum theory suggests that particles exist not as objects, but as probabilities, fields of potential that crystallize into reality only when observed. Some interpretations go further, proposing that every possible outcome occurs, each in its own branching universe. If so, existence itself is an infinite tree of possibilities, each leaf a reality where different choices, different histories, different stars unfold. Whether or not this multiverse is real, its conception marks a turning point in human thought, the realization that reality may be larger than imagination itself. While the cosmos expands outward, human understanding expands inward. We now study the first moments of creation using particle accelerators, recreating conditions of unimaginable density and heat. Collisions at near light speed briefly restore the universe to its infancy, producing exotic particles that existed only microseconds after the Big Bang. Among these are the Higgs boson, the particle that gives others mass, and quarks that bind into protons and neutrons. Through these experiments, we glimpse the blueprint of matter, the architecture underlying all existence. The Large Hadron Collider, buried beneath the fields of Geneva, is not just a machine, it is a window through time, an artificial dawn illuminating the origins of the cosmos. Yet physics is not content with discovery. It seeks unity. The dream of
A theory of everything haunts modern science. One equation to describe all forces: gravitational, electromagnetic, strong, and weak. String theory proposes that all particles are vibrations of infinitesimal strings resonating in dimensions beyond the visible.
The future of exploration is written in ambition. Telescopes planned for the coming decades will peer deeper still. One to capture the faint glow of the first stars, another to study the atmospheres of exoplanets for signs of life. On Mars, rovers analyze rocks for fossils of ancient microbes. In the outer solar system, probes will dive beneath the icy crusts of Europa and Enceladus, seeking warm oceans below. Each mission is a step toward the same question: how common is life in the universe? If we find even the simplest organism beyond Earth, it will transform our understanding of biology, of destiny, of meaning itself. If we find nothing, the silence will be equally profound, a reminder that consciousness may be the universe's rarest bloom. Meanwhile, cosmologists refine their measurements of expansion. The Hubble constant, the rate at which galaxies recede, has become a puzzle. Different methods yield conflicting results. Some suspect new physics is at play, perhaps variations in dark energy, perhaps undiscovered particles influencing the early universe. Each discrepancy is a doorway to discovery, proof that the cosmos still guards its secrets. As we measure its pulse, we learn that the universe is not static, but alive with change. And beyond all our instruments, beyond all equations, lies wonder. Wonder is the force that first lifted human eyes to the stars, that built observatories and theories, that sent ships and signals into the unknown. It is older than language, older than civilization, older than fear. It is the quiet realization that to exist at all is improbable, and to be aware of existence is miraculous. When we gaze into the depths of the universe, we are not looking outward, but backward in time, toward the dawn of all things, and perhaps toward the dawn of ourselves. As human understanding grows, so too does the realization that our cosmic home is fragile, suspended in a narrow equilibrium. Earth's biosphere, nurtured by a single star and shielded by a thin atmosphere, is an anomaly amid the vast sterility of space. For all our telescopes and equations, we have found no second cradle that rivals this one. The pale blue dot, as Carl Sagan called it, is a mote of dust caught in a sunbeam, a reminder that the universe, for all its grandeur, is also delicate. From the perspective of the cosmos, our wars, our empires, our entire species are but fleeting sparks. Yet within those sparks lies something the universe had never known before: the ability to reflect upon itself. Reflection is the essence of cosmology. Each era of discovery reveals not only new facts about the universe, but new facets of ourselves. When Copernicus displaced Earth from the center, humanity learned humility. When Darwin placed us among the animals, we learned kinship. And when Hubble revealed countless galaxies beyond our own, we learned scale. Now, as we probe dark matter and dark energy, we are learning perspective, that even in knowledge, we stand upon islands in an ocean of ignorance. To study the universe is to acknowledge that we are small, yet capable of infinite curiosity. It is an act of reverence disguised as science.
Among the most haunting mysteries is time itself. It flows inexorably forward, yet physics offers no fundamental reason why. The laws of motion are symmetric. They work as well backward as forward. The arrow of time arises from entropy, the tendency of order to decay into disorder. In the beginning, the universe was remarkably uniform, a low-entropy state pregnant with potential. As it expanded, structures formed, stars burned, life arose, all as entropy increased. Our sense of past and future is a consequence of this cosmic drift toward disorder. Yet within that drift, pockets of order persist: stars, planets, minds. Life is a rebellion against entropy, a local reversal sustained by the flow of energy from stars. Even thought itself is an eddy in the stream of decay, a momentary defiance of cosmic indifference. In this sense, every act of creation, an atom forming, a star igniting, a word spoken, is an echo of the universe's earliest act. The Big Bang was not merely the origin of matter, but of potential. It set in motion the conditions for everything that could ever be. And within that spectrum of possibility, one tiny world evolved beings who could ask why. This is the paradox at the heart of existence. From chaos came consciousness. From simplicity, complexity. From void, meaning. Perhaps that is the truest fact about the universe, not its age or size, but its capacity to generate awareness capable of awe. That awe has driven every civilization to look skyward. The Mayans built temples aligned with solstices. The Chinese tracked comets and eclipses. The Arabs named the stars. The Polynesians navigated by them. Astronomy is the oldest science, born from necessity, but sustained by wonder. Even before telescopes, the ancients understood that the heavens obeyed rhythm. The sun returned, the moon waxed and waned, the planets wandered with purpose. From those patterns arose calendars, agriculture, navigation, religion. The stars guided both bodies and souls. In that sense, humanity's first dialogue with the universe was not through instruments, but through imagination. Today, that dialogue continues with far greater precision, but the same longing. Spacecraft orbit Mars, telescopes orbit Earth.
and soon perhaps humans will orbit other stars. We have already touched the moon, sampled asteroids, flown through the tails of comets, and plunged into the atmospheres of giant planets. Each mission adds a verse to the cosmic epic. When the New Horizons probe passed Pluto, it revealed not a barren ice ball, but a world with mountains, plains, and perhaps a subsurface ocean. When the James Webb Telescope opened its golden eye, it captured light that had traveled for nearly 14 billion years. Each image is a letter from the past, each measurement a fragment of the universe's autobiography. Yet for all these advances, the fundamental questions remain. What ignited the Big Bang? What is dark matter made of? What lies beyond the horizon of observation? Will the universe expand forever, or someday reverse into collapse? Each query leads to another, a chain with no final link. Perhaps the pursuit itself is the point. The universe does not owe us answers, but it invites us to seek them. In doing so, we fulfill our role as participants rather than mere observers. We are atoms that have learned to ask, stardust that has learned to dream.
The narrative of the universe is not of perfection, but of persistence. Stars die, galaxies collide, planets perish, yet the process endures. Creation and destruction are not opposites, but partners in the cosmic dance. The same gravity that tears stars apart also binds new ones together. The same supernova that ends a stellar life spreads the seeds of worlds. Even the black hole, that emblem of annihilation, gives birth to jets of matter and energy that enrich the interstellar medium. The universe does not waste, it transforms. Transformation also defines our understanding. Where once we saw the heavens as fixed spheres, now we see them as evolving systems. Where once we imagined gods in the sky, now we find natural laws, laws that, though indifferent, allow beauty. The spiral of a galaxy, the symmetry of a snowflake, the orbit of a moon, all follow mathematical patterns that seem almost poetic. Perhaps this is why so many scientists speak of elegance. To discover order in the vastness is to glimpse something eternal. The equations of physics may be humanity's most enduring art. Still, the universe resists final explanation. Quantum uncertainty ensures that some events have no cause, only probability. At the largest scales, chaos and complexity render predictions meaningless beyond averages. Even with perfect knowledge of the laws, the details remain unknowable. The cosmos is not a clockwork, but a living mosaic, precise yet unpredictable. In that unpredictability lies possibility for novelty, for freedom, for life. And life, fragile though it is, may be the universe's most radical invention. On Earth, it emerged almost as soon as conditions allowed.
suggesting that it may be common wherever environments are stable and energy abundant. Microbes thrive in volcanic vents, in frozen lakes, in radioactive waste. If such resilience is universal, then the cosmos may be rich with life unseen. Yet intelligence, the kind that wonders, may be rare indeed. The silence of the stars, the absence of signals from other civilizations, remains the great enigma known as the Fermi paradox. Perhaps other species have risen and fallen before us, their voices lost to time. Perhaps they exist still, but communication across such distances is beyond practicality. Or perhaps we are the first, the universe's first self-aware experiment. If so, the responsibility is immense. For in our brief moment of awareness, we hold the power to alter not only our planet, but our destiny. The atoms that once lay silent in stellar cores now build telescopes and write poetry. We have inherited the creative impulse of the cosmos itself. Every discovery, every song, every act of understanding adds to the universe's expression of itself. In that sense, science and art are twin languages of the same longing to know and to celebrate existence. Imagine the far future, when humanity or its descendants roam the stars. Perhaps they will harness fusion like the sun, build habitats around distant worlds, or travel through wormholes if such paths prove real. Perhaps they will witness the collision of galaxies from within and record it as a symphony of light. Perhaps they will evolve beyond biology, consciousness migrating into machines or networks of energy. And perhaps in that distant age, they will look back upon this time, the dawn of cosmic awareness, as the universe's awakening. The first time matter realized it could understand itself. Even now, as you listen, photons born in ancient furnaces fall upon your eyes. You are surrounded by the past, bathed in the light of histories too vast to imagine. The atoms within you were forged in stars that died before the sun was born. The calcium in your bones once drifted as dust in the interstellar medium. The iron in your blood once pulsed in the heart of a supernova. You are not separate from the universe. You are its continuation, its consciousness, its memory. Every breath you take recycles atoms older than Earth. Every heartbeat is a vibration in the same cosmic rhythm that moves galaxies. The universe is not a cold void, but a story still being told. Its facts are not mere data, but verses in an unfolding epic, a tale of transformation from nothing to everything, from simplicity to awareness. To study it is to take part in that story, to become both narrator and listener, question and answer. The stars above are not distant strangers. They are reflections of what we are and what we might become. The universe is within you, thinking, dreaming, asking its own questions through the vessel of your mind. And though one day the stars will fade, the light they cast will never truly vanish. It will travel endlessly, diffusing into the fabric of space, a memory of what